So in this video, we're going to look at some fractional powers, and we're going to start off by looking at this question here, the square root of g to the power of 6. And so we're finding the term that multiplies by itself to give g to the power of 6. And g to the power of 3 times g to the power of 3 is what is going to work to multiply to g to the power of 6, because remember, powers add when we multiply letters that are the same. And so that means the square root of g to the power of 6 is g to the power of 3. And so now if we think about this next problem, the square root of t, now t doesn't have a power there, but we can think of it as an invisible kind of power of 1. And so what's going to work? To multiplying to t is we're going to have t to the power of 1/2 times t to the power of 1/2, because half plus half equals 1. So the square root of t is t to the power of half. And this is something that's really important to remember. This question here is that anything that is square rooted can essentially be written as a power of with a power of half there. And if we look at our next one, the cube root of y, what number or what term times by itself 3 times will give y? And so because we're cube rooting, it's going to have to be y to the power of 1/3 times by itself 3 times, because 1/3 plus 1/3 plus 1/3 equals to 1. And so that's another thing you want to kind of remember. Anything that's cube rooted um, always has a power of 1/3. And this kind of leads us to kind of a general rule here, that if we have a letter or variable with a fractional power, where um, whatever's in the denominator of our power is the root that we're dealing with in terms of whether it's square rooting, cube rooting, fourth root, fifth root, etc. And so what that means is we can write these following ones here in surd form. So surd form is basically putting it as a square root, cube root, or whatever kind of root it is. So f to the power of 1/2, hopefully we remember anything to the power of 1/2 is just the same as having a square root of it. And I could write a little 2 there in the front if I wanted to match what was going on here. But since square rooting, we kind of know that if there's no number there, it's just a square root. Okay, 5m to the power of 1/3. The 5 has not been acted on by the power of 1/3, so that's going to not be part of our root there. And since we've got a root of a 3 there on the bottom of our fraction, that means we're dealing with a cube root there. And so that number in our denominator always connects with what's here in front of our root sign. And so in this question here, it's pretty similar. The 2 again is not connected to that power of 1/2, so that's going to be out the front. We've got a 5 there in the bottom of our fraction, so that means we're going to have the 5th root of k. And so now we're looking at evaluating, so figuring out what the value of these different things are. We could do it on our calculator, but we want to be able to show our thinking and work through the process. So 27 to the power of 1/3, so 3 on the bottom, means we're cube rooting 27. And the cube root of 27 happens to be 3, because 3 times 3 times 3 multiplies to give 27. And next one, 32 to the power of 1/5. The 5 there on the bottom means that we have a 5th root of 32. And the answer is 2. 2 times 2 times 2 times 2 times 2 is 32. And this last one here, a power of 1/2, remember that means it's square rooting. So we're square rooting the whole of 36 over 49. And if we have a square root of over the whole thing, that means we're square rooting the individual numerator and the denominator. So 36 over the square root of 49, square root of 36 is 6, square root of 49 is 7. So that